Hey there, have you ever just looked around at, well, everything and wondered, how did we get here? Not just you and me, but all of it. Well, today we're going to take an absolutely incredible journey back in time. We're talking 13.7 billion years back. We're going from the Big Bang all the way to our own cosmic backyard. I mean, really think about it. You look up at the night sky, you see all those stars, maybe a planet or two, the moon. But have you ever really stopped and thought, how did all of this actually get here? Where did the universe, our galaxy, and our little planet come from? Okay, let's dive into this epic story. So our story kicks off about 13.7 billion years ago, before there were any stars or galaxies or anything at all. Scientists are pretty sure that everything, and I mean everything, we know was squeezed into this unbelievably hot, super dense little point. And then, bam, the ultimate beginning. Now this incredible origin story has a name, the Big Bang Theory. It's the top scientific explanation for how our universe got started. And it's not just some wild guess either. It's backed up by some seriously powerful evidence that scientists have been piecing together for decades. Okay, so how do we know the universe is expanding? We've got two huge clues. First, there's the cosmic background radiation. This is like a faint leftover heat, an echo from that massive explosion that we can detect everywhere in space. And second, we have something called the redshift, which is a really cool clue we get from watching the light from faraway galaxies. To get your head around redshift, just think about an ambulance siren. You know how as it gets closer, the pitch gets higher, and as it moves away, the pitch gets lower? Well, light waves do the exact same thing. When we look at distant galaxies, their light is stretched out, shifting towards the red end of the spectrum. And that's the smoking gun. It tells us they're all moving away from us. The universe is definitely expanding. So the universe is getting bigger. But it's not just empty space flying apart. In those first few 100 million years, gravity started doing its thing. It began pulling all that brand new matter together into these massive clumps. And that's how we got the very first cosmic structures, galaxies, and all the stars inside them. And these clumps became galaxies, these unbelievably huge cities made of stars. Our own hometown in space is the Milky Way galaxy. And it is absolutely enormous. We're talking over 100 billion stars. And get this, we're just one of billions and billions of other galaxies out there. So what exactly is a star, anyway? Well, it's basically a giant glowing ball of gas, all held together by its own gravity. The core of a star is so hot, and the pressure is so intense that it acts like a giant engine. It's a process called nuclear fusion, where tiny atoms are smashed together to create heavier ones, releasing a mind-blowing amount of energy. That energy is what we see as starlight. And just to give you an idea of the scale we're dealing with, our sun is considered a medium-sized star, but medium out in space is gigantic to us. You could line up 109 Earths side by side just to get from one edge of the sun to the other. It's just wow. And you know what's really cool is that stars aren't permanent. Just like us, they have a life cycle. They're born, they live for a really, really long time, and then they die. So let's take a look at the life journey of a star, just like our sun. Okay, so a star like our sun starts out as a baby, born from this huge cloud of gas and dust. Gravity pulls it all together until, boom, that nuclear fusion engine kicks in. Then it enters its long, stable adulthood. We call this the main sequence. That's where our sun is right now, just chillin' for a few billion more years. But eventually, it'll start getting old, run low on fuel, and puff up into a red giant. Finally, it'll shed its outer layers, leaving behind just its tiny hot core, a white dwarf, like a glowing ember left in space. So when a star dies, it doesn't just vanish. It actually sends all its material back out into space. And that, right there, is where we come in. The gas and dust from older, dead stars became the building blocks for new stars and for our very own solar system. Pretty cool, right? Let's zoom in and see how our neighborhood got built from all that recycled stardust. About 5 billion years ago, it all started with this giant cloud of cosmic leftovers. As you can see, gravity started pulling it all together. Most of that material got sucked into the center, got super hot, and bam, that became our sun. The rest of the stuff flattened out into this spinning disk, and in that disk, little bits of dust and rock started sticking together, kind of like cosmic dust bunnies. getting bigger and bigger until they eventually formed the planets, moons, and asteroids we have today. Now, as these planets were forming, they didn't all turn out the same. Not even close. In fact, they sorted themselves into two very different families, pretty much depending on where they grew up in this new solar system. Check this out. It really breaks down the two types of planets we have. First, you've got the terrestrial planets. They're the ones close to the sun, like Earth. They're small, rocky, and dense. You could actually stand on them. But then you go farther out and you find the Jovian planets. These guys are a whole different story. They're huge gas giants with no solid surface to stand on. And they have tons of moons. That's your Jupiter, Saturn, Uranus, and Neptune.
Of course, it's not just planets out there. Our solar system is also home to millions of asteroids. Most of them hang out in a belt between Mars and Jupiter. We've also got these icy comets, kind of like dirty snowballs, that loop in from the far edges of the solar system. Then there are all the moons orbiting the planets. And yeah, those shooting stars you sometimes see, they're just tiny little meteoroids burning up as they hit our atmosphere.
Okay, so we've got this whole system. Planets, moons, asteroids, all zooming around the sun. But what holds it all together? Why don't the planets just fly off in a straight line and disappear into deep space? Well, it all comes down to this beautiful cosmic dance. I want you to picture swinging a ball on a string around your head. Your hand is like the sun, and that string is like gravity, always pulling the ball toward the center. The ball wants to fly off in a straight line, that's inertia, but the string keeps pulling it into a circle. That is exactly what an orbit is. It's this perfect, delicate balance between a planet's forward momentum and the sun's constant gravitational pull. And here's a little secret. These orbits aren't perfect circles. They're actually slightly stretched out, more like ovals. The science word for this is elliptical. We even have a way to measure how oval-shaped an orbit is. It's called eccentricity. A perfect circle would have an eccentricity of 0, but every single planet in our solar system has a slightly oval orbit, which means its distance from the sun changes a little bit as it goes through its year. So there you have it, from a single, tiny point to a universe that's still expanding, to the birth and death of stars, to the formation of our very own planet, all held in this amazing dance of gravity and motion. It is an absolutely incredible story. And just remember, our sun is only one of over 100 billion stars in our galaxy alone. That leaves us with one final, big question. What else is out there, just waiting for us to discover?